Good evening and welcome to all of you on my YouTube channel, that is SBJ Physics Classes. Today we will talk about Newton's reaction method in detail with some important questions which comes in previous examination of CSIR NET. So let's talk about Newton's reaction method. As we know that from previous two classes, we discuss about what is Newton's reaction method. So we can say that Newton's reaction method is an approximation method which deals with to evaluate approximate value of a given root function like fx is equal to 0, as this fx equal to 0, or we can take another function fx is equal to x square minus 4 equal to 0. The concept of Newton's reaction method is that it uses an idea that a continuous and differentiable function can be approximated by a straight line tangent to it, like following. जैसे कि हम लोग जान चुके हैं न्यूटन्स रैप्शन मेथड क्या है, एक अप्रोक्सीमेशन मेथड है। बहुत सी ऐसी कंडीशन मैथमेटिकल फिजिक्स में आती हैं जहाँ पे हम एग्जैक्ट वैल्यू इवेलुएट नहीं कर सकते, तो ऐसी स्थिति में हम न्यूटन्स रैप्शन मेथड का यूज़ करते हैं। न्यूटन्स रैप्शन मेथड इज आल्सो known by Newton's method. Simply we can say that Newton's reaction method is a Newton's approximation method. तो इस न्यूटन्स अप्रोक्सीमेशन मेथड का हम यूज़ करते हुए किसी फंक्शन के लिए अप्रोक्सीमेट वैल्यू मेजर करते हैं। उसके लिए हम करते क्या है, फर्स्ट ऑफ ऑल वी टेक इन फंक्शन दैट is continuous differentiable like fx is equal to 0, or like this fx equal to x square minus 4, then we get x equal to 2. So this 2 is the root value of fx. तो को हम मान लेंगे रूट वैल्यू है किसकी, दिए गए फंक्शन की। तो इसकी जो अप्रॉक्सीमेट वैल्यू आएगी वो 2 के आसपास आती है, या तो 2 से ऊपर होगी या तो 2 से नीचे होगी। तो इसके लिए हम क्या करते हैं, इटरेशन फार्मूला यूज़ करते हैं, न्यूटन्स इटरेशन फार्मूला। तो सबसे पहले हम क्या करते हैं, न्यूटन्स रैप्शन मेथड को समझने के लिए, जो कि हम पहले भी समझ चुके हैं, एक फंक्शन लिया, एक्स वाई प्लेन लिया, और उस फंक्शन के द्वारा जो कर्व डेवलप होता है, यानी दैट इज कंटिन्यूस एंड डिफरेंशिएबल कर्व, वो हम मान लेते हैं इस एक्स वाई प्लेन में ये है, और इस एफ एक्स इज इक्वल टू 0 कर्व पे एक स्ट्रेट लाइन दैट इज टेंजेंट, जो कि इस कर्व को ए पॉइंट पे टच करती है। ए पॉइंट पे टच करने के साथ साथ ये स्ट्रेट लाइन ओ एक्स यानी एक्स एक्सिस को इंटरसेक्ट करती है बी पॉइंट पे। तो इसके लिए हम क्या करेंगे, सबसे पहले एक्स वाई प्लेन लिया, कर्व ड्रा किया, एक टेंजेंट लाइन ड्रा किया जो कि इस कर्व को ए पॉइंट पे टच करती है और एक्स एक्सिस को इंटरसेक्ट करती है। तो हर एक पॉइंट का हम कोऑर्डिनेट निकाल सकते हैं। सो लेट कोऑर्डिनेट ऑफ पॉइंट ए इज एक्स नॉट एंड एफ एक्स नॉट, कोऑर्डिनेट ऑफ बी इज एक्स 0 and coordinate of D, that is normal line draw from A to x-axis, that is AD. Then coordinate of D point is x naught D, x naught 0, where x naught is the value at x-axis and 0 is the value at y-axis. Now Now we can evaluate the equation of tangent. As knowledge, previous discussion, we know that the equation of tangent can be evaluated through a point. If we have any point and having some coordinate, then we can easily evaluate equation of tangent, as we have 2 points A and B, and through which this tangent line crosses. So we can easily evaluate the equation of tangent through this general formula, that is y minus y1 is equal to dy upon dx x minus x1, or we can change it in this form, that is dy upon dx equal to y minus y1 upon x minus x1. So let this be equation first. Now we can take equation of tangent as y minus fx naught, because we have the value of y1 in above fx naught. So equation of tangent y minus fx naught equal to f dash x naught x minus x naught. So let this is the equation second, as this tangent line intersect x axis at point B, so it satisfy also this point. So we can change this equation of tangent equation of tangent like this: 0 minus fx 0 minus fx 0 minus fx naught equal to f dash x naught x1 minus x naught और x minus x naught, where x naught क्या है, x naught को हम पहले ही मान चुके हैं. This is the initial approximation, so we can change it in another form, that is x1 minus x naught equal to minus fx naught upon f dash x naught. Then x1 equal to x naught minus fx naught upon f dash x naught. So this is the required expression, and we can say that this is the initial approximation. This is the first approximation for the given curve. Similarly, we can evaluate another approximation, that is second, third, fourth, and so on. So we use x2 equal to x1 minus fx1 f dash x1 and x3 equal to x2 minus fx2 upon f dash x2. Here x1 x2, these are the initial approximation, that is first approximation. This x2 is the second approximation. As we move further, as we move in as we then we get approximate value. Now we can evaluate a general formula, that is xn plus 1 is equal to xn minus fxn upon f dash xn. This is the iteration formula of Newton's Raphson method. This is the famous formula of Newton's Raphson method. So by using this iteration formula, we can iterate any function that is continuous and differentiable, and we can evaluate the value of approximation for that curve. So we can also evaluate or derive this equation, this iteration formula, that is f x that is x n plus 1 equal to x n minus f x n upon f dash x n by using second method. So let's talk second method to evaluate this iteration formula by using Taylor series. This is the second method to evaluate to derive iteration formula of Newton's raphson method, that is xn plus 1 is equal to xn minus fxn upon f dash xn. So to derive this formula we use second method as following. For this, first of all we take an equation fx is equal to 0, that is continuous and differentiable. So let x naught be the initial approximation to the root. So again let first approximation x1, and x1 is equal to x naught plus h. Now this is the second equation and this is the first equation, that is fx is equal to 0, in which x naught is the initial approximation. So be putting or be substituting this value of x1 in above equation first, then we get equation third as fx naught plus h is equal to 0. This is the equation number third. Now we can evaluate the value of h, which shows a small variation from x naught in positive direction or negative direction by expanding this function by using Taylor series and neglecting high terms of h, then we get. So we can expand fx naught plus h by using Taylor series h fx naught plus h f dash x naught plus h square upon factorial 2f double dash x naught plus h cube and upon factorial 3f triple dash x naught and so on equal to 0. But we have neglecting higher terms of h, so from this we get fx naught plus h is equal to fx naught plus h f dash x naught equal to 0. So from this equation we can easily evaluate the value of h as following. H is equal to minus f x naught upon f dash x naught from this equation. Now using this value of h in above equation second, that is x1 equal to x naught plus h, then we get x1 equal to x naught minus fx naught upon f dash x naught. This is the first approximation to the root. This is the first approximation to the root of the given equation. Now, in same way, we can evaluate second approximation as following, also third, fourth, and so on. So, x2 equal to x1, where x1 क्या है? x1 हमारा first approximation. So x2 equal to x1 minus fx1 upon f dash x1, and similarly x3, x4 and xn. But in terms nth term we get n minus 1, xn equal to n xn minus 1 minus fxn minus 1 upon f dash n minus 1. So we take a standard form xn plus 1 equal to xn minus fxn upon f dash xn, and this is the required iteration formula for the Newton-Raphson method, which is very useful in numerical mathematics, in numerical physics, mathematical physics. So we use this formula for solving important questions. In above we discuss about Taylor series. What is Taylor series? In short, we can explain it as, if fx be analytic, means we have any function that is fx and it is analytic inside and on to a simple closed curve that is C at every point. So let A and B be any two points at which this function be analytic enclosed through this curve that is C. So for this curve, according to Taylor series, we have f a plus h is equal to f a plus h f dash a plus h square upon factorial 2 f double dash a plus h cube upon factorial 3 f triple dash a and so on. So we again talk about some important question which comes in previous examinations of CSIR net based on Newton's raption method. So question is this. This question comes in CSIR net. CSIR net December 2019. Now we read question. The the positive zero of the polynomial fx equal to x square minus 4. यहाँ पे इस क्वेश्चन में दिया क्या गया है कि पॉजिटिव जीरो ऑफ द पॉलिनोमियल एफ एक्स इज इक्वल टू एक्स स्क्वायर माइनस 4 is determined using Newton's raption method using an initial guesses that is x equal to first. Let the estimate after two iteration be x second, or we can say that second iteration of x. Then the percentage error, that is second iteration of x minus 2 upon x into 100. This is the general formula to derive percentage error, and these are the options of this question, that is first 7.5%, second 5.0%, third 1.0%, fourth 2.5%. Now for the solution of these questions, for this question we can use Newton raption method as we discussed above, that is given as we know that Newton raption method is a way to find a good approximation for the root of real valued function like fx is equal to 0. ये हम पहले ही जान चुके हैं कि न्यूटन रैप्शन मेथड क्या है. एक अप्रोक्सीमेशन मेथड है जिसमें हम रूट ऑफ रियल वैल्यूड फंक्शन fx इज इक्वल टू 0 के लिए अप्रॉक्सीमेट वैल्यू मेज़र करते हैं. एंड in this method we uses the idea that continuous and differentiable function can be approximated by a straight line tangent to it by using iteration formula, that is xn plus 1 equal to xn minus fxn upon f dash xn. तो इन सब फैक्टर्स का हम यूज़ इस क्वेश्चन में करेंगे और निकालेंगे क्या, परसेंटेज एरर. किसके लिए, सेकेंड इटरेशन के लिए. इस क्वेश्चन से हमारे पास है क्या, हमारे पास दिया गया है एफ एक्स इक्वल टू एक्स स्क्वायर माइनस 4. So let y is equal to fx naught and it will be x square minus 4. Hence x is equal to 2. This is the root of the given function fx. इस fx के लिए दो क्या है, x naught equal to 2 is the root of the given function. But we have iteration formula from Newton's raption method, that is xn plus 1 equal to xn minus fxn upon f dash xn. So first of all we take x equal to 1 and then we have first iteration as iteration of x, that is iteration of x x1 or x इटरेशन ऑफ एक्स। फर्स्ट इटरेशन में हम क्या करते हैं, एक्स फर्स्ट इटरेशन हम इस कुछ इस तरीके से निकालते हैं। फर्स्ट इटरेशन ऑफ एक्स इक्वली टू x minus fx upon f dash x, but we have fx. When x is equal to 1, then we have fx is equal to 3 minus 3, fx equal to minus 3 when x equal to 1, and f dash 1 equal to 2. Now putting these values in this equation, then we get first iteration, that is x1 equal to 1 plus 3 upon 2, that is 5 upon 2. Now after solving this we get 2.5, and this is the first approximation value of the root equation. Now in same way we can easily evaluate second iteration for the given function, that is x2. For the second iteration we use first iteration as this. Second iteration x2 is equal to first iteration minus f of first iteration upon f dash first iteration, but we have fx naught is equal to x square minus 4, so by using this we get first iteration equal to 2.5, and fx1 means function of first iteration. So by solving this f 2.5, because first iteration x1 equal to 2.5, so 2.5 is using in above equation, that is x square minus 4, then we get 2.5 square minus 4, and after solving this we get 2.25, 2.25. So and also we have f dash iteration of x, f dash 2.5. So by solving this we get 2 into 2.5, that is 5. Now putting these values in above equation, this x2 equal to x1 minus fx1 upon f dash x1, then we get x2 or second iteration of x as x2 equal to 2.5 minus 2.25 upon 5. So after solving this we get 12.5 minus 2.25 upon 5, and this becomes 9.25 upon 5. Hence we have second iteration equal to 1.85. This is the value of second iteration. Hence percentage error will be given as second iteration minus 2 upon 2 into 100 can be taken as 1.85 minus 2 upon 2, and this becomes negative, but there is a mod, so this becomes positive, and it is multiplied by 100, so it becomes positive, and we get 7.5%, and this is the answer, and this is option first. So answer is first of this question by using Newton's Raphson method. So thank you. We talk about another questions based on Newton's Raphson method in next video. So please like and subscribe my YouTube channel, that is SPJ Physics Classes. So thank you.